So today we're going to start section 1 of chapter 9. Today we're going to learn about the Pythagorean Theorem. So many of you may have already seen the Pythagorean Theorem before, possibly in your Algebra 1 course or in a pre-algebra course. And we did briefly talk about it. The Pythagorean Theorem is a squared plus b squared equals c squared, and you can only use this for right triangles. So in a right triangle, the square of the lengths of the hypotenuse is equal to the sum of the squares of the lengths of the legs. So in this picture, my legs are the A and the B. They are the sides that are forming this right angle. And then the longest side of my right triangle, the side across from the right angle, this is my C, and this is called the hypotenuse. The hypotenuse is always the biggest side of the triangle. And it's always across from the biggest angle. And in a right triangle, the right angle is the biggest angle. Now, you can switch up the location of the A and the B value. So you could also have drawn your triangle like this and said, well, I want this to be A and this to be B. But this side here always has to be the C. You can't move the C value. The next slide actually has some common Pythagorean triples. These are Pythagorean triples. And a Pythagorean triple is actually 3 integers that satisfy the Pythagorean theorem. So once I plug these 3 numbers in to a squared plus b squared, they will equal the c squared. And when you're given a list of 3 numbers, the biggest number is always the c. And they have to be integers. So a Pythagorean triple cannot be a decimal, and it can't be a square root. So they have to be integers. Now, I am not going to make you memorize these common triples, but just be aware of them because especially this first one. This one shows up on SAT and PSAT, lots of standardized tests, a lot. So if you recognize that if they gave you a picture of a right triangle, and let's say they had 2 of the sides labeled, and then they wanted you to find this missing side, if you recognize that this was the 3, 4, 5 triangle, then you don't have to worry about plugging these numbers into the Pythagorean theorem. So recognizing some Pythagorean triples could save time on a standardized test. The one right below it is just a scaled up version of the 3, 4, 5. All they did was take the numbers and multiply them by 2. And then other common Pythagorean triples would be the 5, 12, 13 triangle, the 8, 15, 17, and then the 7, 24, 25. Now, if you're going to use this fact that you're going to memorize that a 3, 4, 5 could be a right triangle, just remember that the 5 needs to be on the hypotenuse. If they would have labeled it and said this was 3 and this was 5, in order to find this side, you have to do Pythagorean theorem. You can't say that this missing side of x is the 4 because remember, this side needs to have the biggest number on it. So you couldn't place the 3, 4, and 5 that way. The 5 would have had to have been the hypotenuse. Now, before I move on to example 1, I need to do a little bit of Algebra 1 review with you before I cover using the Pythagorean theorem. Just to review some concepts to make sure we're clear on these Algebra 1 skills. So let me add a slide. So the first thing I want to review with you is when you have a binomial. So let's say this is x plus 2, and I want to square it. The most common mistake that students make when it's a binomial squared is they think they could just take the x and square it, the 2 and square it, and they're done. If you do that, You just got it wrong. So, and this is going to be a major common mistake that a lot of students are going to do when they get back into Algebra 2 because they're going to have forgotten their Algebra 1 skills. So when you have a binomial squared, you're either going to memorize the pattern it creates, but what's easiest to do is remember that anytime something is squared, you're just going to write it 2 times, and now we have to multiply. Now I'm going to multiply these 2 binomials. You can either just use distributive property, or your Algebra 1 teacher might have taught you an acronym called FOIL. So it's either applying distributive property. So if you're going to use FOIL, you're going to be doing the first term on each one of the binomials. So the F in the word FOIL stands for first. So I'm multiplying the first. So x times x is x squared. You can also think of distributing the x to the x. And now you have to distribute the x also to the 2. Or also think of these as the 2 outer numbers. So these are the 2 outside numbers in the acronym. So this would give me positive 2x. And then you can do the 2 inside numbers and get positive 2x. So that's what the I stands for. And inside, or let's do inside. And then finally, to get the last term, we would do last. So the 2 times 2, that's the L in the acronym, and it stands for last. So that would give me positive 4. Once we do this distributive property or this acronym FOIL, we'll always be able to combine the 2 middle terms. So this gives me x squared plus 4x plus 4. So either use the acronym FOIL or just do distributive property. So some of the legs or the hypotenuse might be a binomial, and you're going to have to square it once you plug it into the formula. So be able to square a binomial, which is then going to give you a trinomial. The other thing I want to review with you is when you square a radical. So let's say we have the square root of 5, and I want you to square that. So again, it means square root of 5 times square root of 5. If you remember back from the beginning of the year, remember whenever you make a pair of square roots, that just comes out of the radical. And the answer here is 5. Another way you can think of this is think of this as multiplying the 5 and the 5. Then it's the square root of 25. And again, you get 5 as well. But I wouldn't waste time multiplying them. Just know that whenever you have a radical that is squared, squaring that square root cancels it. And then it just frees up the number. Let's now say that the binomial, or not the binomial, let's say we have a number and a square root. And we want to square it. So again, this, we're going to do 3 square root 2 times 3 square root 2. We're going to multiply the 2 outsides together. 3 times 3 gives me 9. And then again, you can either think of this as a pair of square root 2's. So the 2 comes out. And the final answer here is 18. So be able to square all these different things because that's what we're going to be doing to the sides of the triangle when we apply the Pythagorean theorem. So for the first example, example 1a, let me zoom in here. So here is my right triangle. Again, the Pythagorean theorem only works for right triangles. Remember the side across from the right angle, this is going to be our C in the formula. So what we're using for the 3 problems on this slide are going to be a squared plus b squared equals c squared. Now, when you get these problems in the big ideas or on a standardized test, they're not going to label the sides with a, b, and c. They're going to use different variables for the unknown. The main thing you need to remember is the side across from the right angle is always C, and it doesn't matter for the other two. If I say that the 5 is my A and the 10 is my B, or vice versa. Here it doesn't matter for A and B. So now that I've labeled the three sides, now I can plug it in to A squared plus B squared equals C squared, and then solve. So A I said was 5, B is the 10, and the C squared, or the C, is my Y. I need to follow order of operations. I can't add 5 and 10 first. I have to square them first. Then I add the numbers. I get 125 is equal to Y squared. Now at this point, I need to find the value of Y, not Y squared. So in order to get Y, I need to square root both sides. And then I get 125, the square root of it, is equal to Y. Now, technically, whenever you solve for a variable, whenever you solve for a variable squared, what ends up coming out of that is both a positive square root of 125 and a negative square root of 125. However, in Algebra 2, we would keep both. But in geometry, we don't want to work with the negative square root because I don't want a negative side of my triangle. So whenever I'm doing any of these Pythagorean theorem questions, I'm only keeping the positive square root value. Now, if Big Ideas says to leave your answer exact, this is where we're going to leave it in simplest radical form. And this is what we did at the beginning of the year when we did the distance formula. So remember, simplest radical form, we need to break down and do a factor tree for the 125. So two numbers that will multiply to give me 125. I know that 25 times 5 gives me 125. I have to keep breaking it down. Now, if you recognize that 25 was a perfect square, at that point you could square root it and go right to your answer. But if you are someone who prefers to keep breaking it down until it's totally prime, you can do that. And then now you're going to go back and you're going to look for pairs. So I have a pair of 5s, and when you make a pair, one of them comes out without the radical, and then anything else that doesn't pair up stays underneath. So the answer to this problem, left exact, Y is equal to 5 square root 5. Now, if the question says round your answer, and they'll tell you a specific place. If it doesn't specify and it just says round, if it says round your answer, then they want the tens place. If they want a place other than the tens place, they will specify. So let's say it says round your answer to the tens place. Whenever it says round, this is going to be a calculator question. So you'll get out your calculator. You're going to do the square root of 125 on your calculator. Once you do the square root of 125, you are going to get 11.180333989. And then you're going to round to the tens place, which is the 1. And then the 1 will look at the 8, and the 8 will tell the 1 we're rounding up. So if it says round, then it's 11.2. Now, I know you're using your calculator for the homework. However, I want to see how you're plugging the numbers into a squared plus b squared equals c squared, and then show me the solving process. Because technically you're not using your calculator until the end if the question says to round. If it says exact, you're going to show me how you break it down. Everybody good and see the difference? So when you do the big ideas homework, make sure you're reading how they want the answers entered. On the quiz, you're leaving them exact. You're going to enter them in radical form. You'll still have your calculator on the quiz, but again, your calculator will not break it down in simplest radical form. When you do it on your calculator, it gives you the decimal equivalent. Let's try the next one. This is where we have to do our FOIL acronym, or just distribute. So again, remember the side across from the right angle. This is my C. This could be my B, and this could be my A. So again, I'm going to be plugging it in to A squared plus B squared equals C squared. I'm going to be plugging in 5 for A, Y minus 1 for B, and then Y for the C. Remember, we need to take Y minus 1, and we're going to square it. So Y minus 1 squared, we need to write it twice, and you're either going to apply distributive property or FOIL. So if I do the FOIL acronym, first, outside, inside, and last, and then combine the middles. So Y squared minus 2Y plus 1 is what it becomes when you square it. So let me square the 5, and I get 25. I'm replacing the Y minus 1 squared with what I just got. So Y squared minus 2Y plus 1, and it equals Y squared. My goal is to solve for Y. So now I need to combine some like terms. I can combine my constants here, 25 and 1. They're on the same side of the equal sign. So I'm just going to add them together. I get 26, and I still have the Y squared minus 2Y equals Y squared. I now need to try to get my Y squareds together. So I'm going to subtract Y squared from both sides. Notice it cancels on both sides. So now I'm left with 26 minus 2Y, and then Y squared minus Y squared is 0. I still need to get Y by itself, so I'm going to add 2Y to both sides. And now I have 26 is equal to 2Y. Divide both sides by 2, and Y equals 13. So that is the length of my hypotenuse. If it asked me to fill in the other side as well, then I would have done Y minus 12, 13 minus 12 here, or minus 1, and this side would have been 12. This side's the 13. Again, this is a common triple. But again, it only asks you to find Y, so the answer is 13. Let's try part C, where, again, I'm going to apply the Pythagorean Theorem. So again, I could say the X side here is my A, this is my B, and this could be my C. It's across from the right angle. So again, I'm plugging it into A squared plus B squared equals C squared. So I'll plug in X for the A, 3 for the B, and my C is 3 square root 2. So I gotta square that radical. So what that really means is, for this, I'm doing 3 square root 2 times 3 square root 2. I do outside and outside together, and I get, let me fix that. So I get 3 square root 2 times 3 square root 2. Do the two outside numbers together, and then I'll do the two inside. And again, pair of square root 2's, the 2 comes out, and I get 18. So now, X squared, I leave. 3, I got to square it. It becomes 9. And then this becomes 18. Now I have a nice simple equation to solve. Subtract 9 from both sides. I'm left with X squared equals 9. I don't want x. I don't want x squared. I want x. Square root both sides, and x is equal to 3. And I'm done. So this one, it says, find the length of a diagonal of a rectangle with length 8 and width 4. So let me go ahead and draw a rectangle here. So here is my rectangle, and it said that it has a length of 8 and a width of 4. Now remember, in a rectangle, it's a parallelogram and opposite sides are congruent. So I could have put the width over here and the length here. It doesn't matter. Now it says to find the length of the diagonal. One other thing that we covered when we did quadrilaterals, remember that the diagonals of a rectangle, no matter if I draw it that way or this way, these diagonals are always congruent. So I'm just going to draw in one of the diagonals. Also remember, other properties of a rectangle is each one of these corners here are right angles. So by drawing in that blue diagonal, I have now created 2 small right triangles. So I have one here, and then I have another one up here. Now I don't need to work with both. I just want to find the length of that blue line, and that's the hypotenuse. So let's say I pull the blue one out. So if I draw it over here, this is 4, this is 8, and I'm looking for the diagonal, which is my hypotenuse. So it's my C. So I'm now going to say the 4 could be my A, the 8 could be my B, and now let's plug it in. So A squared, which is 4, plus B squared, which is 8, equals C squared. I need to square the numbers first. Then I can add them. And then I square root it. So if the instruction said, leave your answer exact, C is equal to the square root of 80, I got to break down the 80. I need to do a factor tree. Now, for me, I know that 16 times 16 times 5 is 80. So since I already know that the biggest factor that's a perfect square is 16, I could go right to my answer. So the answer here in exact form is 4 square root 5. But let's say you didn't recognize that it was 16 times 5. Let's say instead you did 8 times 10. If you don't pick the biggest perfect square, then we're going to keep breaking it down till it's prime. So 8 becomes 2 times 4. 10 is 2 times 5. 2 is already prime. 4 is not, so I got to break it down one more time. Bring down that 2, bring down that 5. Now I go back and look for pairs. I have a pair of 2's here, so a 2 comes out of that. I've got a pair of 2's here, a 2 comes out of that. Nothing to pair with this 5, so he stays underneath. All the numbers that came out get multiplied back, and notice it's the same answer I got when I did 16 times 5. Now, this is the exact answer, but let's say instead it said find the length and round it to the tenths. You would use your calculator. So you would do the square root of 80, and it gives you 8.944279191. Rounded to the tenths place, the 9 looks at the 4 tells the 9, you're going to stay at 8.9. So here, my diagonal has a length of 8.9. The next one is a rhombus. So let's go ahead and draw in a rhombus here. Remember, the sides of a rhombus are always equal. Another property of a rhombus is you need to know that the diagonals are perpendicular. So this is forming little right triangles in here. So I actually have 4 congruent right triangles. My diagonals have a length of 16 and 30. So let's say the one going horizontally is going to be the 30. So then this would be 15. This one would be 15. And then the one that has a length of 16, that would mean that this is 8 and this is 8. So all I have to work with now is this little triangle that's right here, any one of them. It doesn't really matter. So if I pull it out, I'm trying to find the hypotenuse because that's going to give me the length of all 4 sides of my rhombus. And then I can go back and find the perimeter. So this is my A, this is my B, and this is my C. So again, A squared plus B squared equals C squared. 8 squared plus 15 squared equals C squared. 64 plus 225 equals C squared. 289 equals C squared. Square root it, and the value of C, or that side of the rhombus, is 17. So all 4 sides are 17. So to find the perimeter, either do 17 times 4, and it's 68, or add 17, 17, 17, 17. Either way, you get 68 for the perimeter of the rhombus.